Pipe laying and beddings. Pipe should be laid in 3 meter maximum length with the joints pushed home into the sockets. Furthermore, care must be taken to ensure the pipe jointing seals are free from grit, silt, etc., which will likely cause the pipeline to fail later air testing. It is recommended that sewers are air tested at regular intervals as pipes are laid. Pipe laying and beddings. Pipes should be cleanly cut, be free from defects, and laid without backfall and dips. Jointing of pipe. Pipes should be laid in 3 meter maximum lengths with the joints pushed home into sockets. Furthermore, care must be taken to ensure the pipe jointing seals are free from grit, silt, etc., which will likely cause the pipeline to fail later air testing. Third, it is recommended that sewers are air tested at regular intervals as pipes are laid. Fourth, pipes should be cleanly cut, be free from defects, and laid without backfall and dips. Testing of sewer. First, the straightness of the sewer pipe can be tested by placing a mirror at one end of the sewer line and a lamp at the other end. Second, if the pipeline is straight, the full circle of light will be observed. Third, however, if the pipeline is non-straight, this would be apparent and the mirror will also indicate any obstruction in the pipe barrel. Then is the testing of sewer. This one is the testing of sewer. Testing of sewer. First, any obstruction present in the pipe can also be tested by inserting at the upper end of the sewer a smooth ball of diameter 30 mm less than internal diameter of the sewer pipe. Second, in absence of any obstruction such as yam or mortar projecting through the joints, etc., the ball shall roll down the invert of sewer pipe and emerge at the lower end. Presentation outlines. First, definition of sewer appurtenances. Second, necessity of sewer appurtenances. Third, manhole. Fourth, drove manhole. Fifth, lamp hole. Sixth, street inlets. Seventh, catch basin. Eighth, flushing device. Ninth, sand, grease and oil trace. 10th, inverted siphon. 11th, sewer outlet. 12th, ventilating shaft. Sewer appurtenances. Definition. Sewer appurtenances are the various essential accessories or devices for the proper maintenance and efficient operation of sewerage system. Necessity of sewer appurtenances. First, to inspect the sewer. Second, to help in cleaning the sewers. Necessity of sewer appurtenances. First, to inspect the sewer. Second, to help in cleaning the sewers. This is inspection of sewer. Manhole. Manholes are masonry or RC chamber constructed at suitable intervals along the sewer lines for providing access into them. Manholes are classified as follows: shallow manhole, normal manhole, deep manhole. Shallow manhole. It is about 0.70 meter to 0.90 meter depth. Second, it is constructed at the start of a branch sewer or at places which are not subjected to heavy traffic. Such a manhole is provided with a light cover at its top and is called as inspection chamber. Generally, shallow manholes types of manholes are provided at the domestic areas. Deep manhole. Deep manhole. It is having depth more than 1.5 meter. The section of such a manhole is generally not kept the same. The size in the upper portion is reduced by providing an offset. Steps, etc. are provided in such a manhole for facilitating descending into manhole and to enable the workers to go up into its bottom. Manhole. It permits inspection and cleaning as well as the repair of sewers and removal of any obstruction, and also they allow sampling and flow measurement. Second, most manholes are circular in shape with the inside diameter of 4 feet 1.25 meter has been widely adopted. Third, these are provided at every bend, junction, change of gradient or change of diameter of the sewer. Fourth, the sewer line between two manholes is laid straight with even gradient. Fifth, it consists of working chamber, an access shaft and a stone cover on the top. Fifth, it consists of working chamber, an access shaft and a stone cover on the top. Sixth, the lower portion of a deep manhole is known as the working chamber, and it provides a working space to carry out cleaning and inspection of sewer line. Seventh, access shafts provides access to the working chamber. Eighth, the manhole cover of RCs provide to cover the opening. Then is a concrete base. This is main sewer. This is benching. This is branch sewer. This is wall. These are the steps. This one is RCC slab. This is manhole cover. This is access shaft. This is offset. Again. This is concrete base. This is main sewer. This is benching. This is branch sewer. This is wall. These are the steps. This is RCC slab. This is manhole cover. This is access shaft. This is offset. This is A. Then this is branch sewer. Then this is main sewer. This is benching. This is section AA. Drop manhole. First, when it is uneconomical or impracticable to arrange the connection with the 60 cm of invert of the sewer and manhole, then vertical shaft is constructed outside the manhole chamber through which the sewage of a branch sewer is allowed to enter the manhole. Second, such a manholes which drop the level of invert of the incoming sewer by providing a vertical shaft are called drop manhole. Third, the main purpose of a drop manhole is to avoid the splashing of sewage on the manwork. This is concrete base. This is benching. This is main sewer. These are the steps. This is wall. This is manhole cover. This is flue. This is inspection arm. This is branch sewer. This is vertical pipe. Then is the lamp holes. Lamp holes are the small openings on sewers to permit the insertion of a lamp into a sewer. The lamp light is then viewed from the upstream as well as the downstream manholes. The obstructed light confirms the obstructions in the sewers. Then is the lamp hole. First, a lamp holes are the openings or holes are constructed in a sewer for the purpose of lowering a lamp inside it. Second, it is a vertical stoneware or concrete pipes which are connected to the sewer line. Third, the pipes are surrounded by concrete to make them stable. Fourth, at the ground level, the manhole cover with the frame is provided to take up the load of traffic. This is the lamp hole. This is sewer. This is pipe. This is concrete surrounding pipe. This is manhole cover. Then is the street inlets. Inlets are openings on the road surface at the lowest point for draining rainwater from the roads and admitting it into the underground storm water sewers. There are two types of street inlets, like vertical inlet first, second horizontal inlet. Then is the street inlets. This is to storm water sewer. This is concrete box. This is road camber. This is comb with openings and carvings. This is footpath. This is to storm water sewer. This one is concrete box. This is road chamber. This is corner with gratings. This is footpath. Note: Note here, this is curb inlet. This one is the curb inlet, in which there is to stormwater sewer, the concrete box, then road camber, then curb with openings and carvings. This is footpath. Then is the gutter inlet. This is concrete box. This is road camber. This is coir with gratings. This is footpath. This is to stormwater sewer. This is gutter inlet. This is street inlets. This is street inlet. This is street inlet. This is catch basin. Catch basins are used to interrupt the flow of sewage before it enters the sewer, causing deposition of suspending grit and sludge and detention of floating rubbish which could enter and clog the sewer. However, their use is discouraged because of the nuisance due to mosquito breeding, apart from posing substantial maintenance problems. At the bottom of basin, space is provided for the accumulation of impurities. This is for catch basins. Perforated cover. Fourth one for catch basins is perforated cover is provided at the top of the basin to admit rainwater into the basin. This is the catch basin diagram. This is catch basin. This is concrete base. These are the impurities. Here is a to storm water sewer. Here is a sidewall. Here is a road camber. Here is cover with gratings. Here is a footpath. Here is the hood. This is catch basin. Then is the flushing device. Arrangement which holds water and then throws it into sewer for flushing it. Sewers need flushing when certain reaches of a sewer have unfavorable combination of slow slope and low tributary sewage flow, that is, have chances of blockage. Also placed at that end point of sewer. Two methods of flushing are hand operated flushing operation, automatic flushing tanks. This is the flushing device. This is automatic flushing. This is U-tube. This is sniff hole. This is bell. This is discharge level. This is cover. This is ground level. This is an larger pipe. This is sewer line. This is overflow pipe. Overall this is flushing device. Then is the flushing tanks. It is provided when there are chances of blockage, when the self-cleansing velocity of sewer is very less, or when the pipe is late state. It is also placed at dead end points of sewer. These devices store water temporarily and throw it into sewer for the purpose of flushing and cleaning the sewer. Types of flushing operations are automatic flushing tank, hand operated flushing tank. Then is the automatic flushing tank. The flushing operation is carried out automatic at regular intervals. Second, the entry of water is so regulated as to fill the tank up to the discharge point in a period equal to the flushing interval. An overflow pipe is also provided to drain away water in the case the tank fails to discharge and thereby overflow. Then is the cleanouts. A cleanout is an inclined pipe extending from the ground and connected to the underground sewer. It is used for cleaning sewer pipes. This is flow. This is 45-degree elbow. This is removable cover. This is ground surface. This is drain pipe. This is cleanout plug. This is main drain. Note. This is removable cover of cleanout. This is grease and oil traps. Grease and oil traps are those trap chambers which are constructed in a sewage system to remove grease and oil from the sewage before it enters into the sewer line. Such traps are located near the sources, contributing grease and oil to the sewage. Then is the concrete base. This is sewer. This is oil and grease. This is ground level. This is inlet with grating. This is cover. This is outlet. Here it is the partition between maybe the two liquids. This is grease and oil. This is grease and oil traps. Then is the sand, grease and oil traps. If sand is also desired to be excluded from the sewage, that space should be kept at the bottom of the chamber for sand to be deposited. This is sand, grease and oil traps. This is commercial sand or oil or grit interceptor. This is inlet sewer line. This is impact baffle line. This is oil layer. This is front main hole. This is lid. This is mere main hole. This is lid. This is grit chamber. These are solids. This is oil separation chamber. This is baffle wall. This is effluent. This is flow direction. This is bare main hole. This is outlet baffle. This is outlet sewer line. This is outline sewer line to city sewer. This one is outlet sewer line to city sewer. Then is the inverted siphons. An inverted siphon is thus a sewer section constructed lower than the adjacent sewer sections, and it runs full under gravity with a pressure greater than the atmosphere. Note, this is an on a large scale. This is inverted siphon. Here 1, 2 and 3 are channels. Here are the pipes. This is inlet chamber. This is B. This is B. This is A. This is pipe 1. This is pipe 2. This is pipe 3. This is outlet chamber. This is cover. This is sloping pipe length. This is flat pipe length. This is flat pipe length. This is concrete cover. This is concrete cover surrounding the siphon pipes. This is outlet chamber. This is inlet chamber. This is cover. This is ground depression. These are the inverted siphon. Section BB on a large scale. Then is the sewer outlet. This first, storm water and treated water may be discharged into small or large water bodies via sewer outlet. Second, outlets to small streams are similar to the culverts, consisting of a simple concrete head wall and apron to prevent erosion. Third, sewers discharging into larger bodies of water are usually extended beyond the banks into fairly deep water where dispersion and diffusion will aid in the mixing sewage with the surrounding water. This is sewer outlet. Then is a ventilating shaft. First, the ventilating shaft is desirable to prevent the accumulation of dangerous explosive or corrosive gases. Second, the ventilating shaft prevents the creation of pressures above or below the atmospheric that may break seal in plumbing traps. In case of storm water, this can be done by providing ventilating manhole covers. Note, this is ventilating shaft. Then is a stormwater regulator. They are constructed in the combined sewage systems and permit the diversion of excess stream water into a nearby stream. Stormwater regulators may of the following types: leaping weir, overflow weir, siphon spillway. Characteristics of sewage. The characteristics of sewage can be classified under the following three heads: physical characteristics, chemical characteristics, biological characteristics. Physical characteristics. The physical characteristics of sewage are determined using the physical method of analysis. Color. First, the color of sewage indicates the freshness of the sewage. If its color is greyish, brown or yellowish, it indicates fresh sewage. With passage of time, as a putrefaction starts, it begins to get black. The color of stale and septic sewage is black. When all the oxygen has disappeared from the sewage, it becomes septic. Other colors may also be found due to presence of some specific industrial waste. The color of sewage can normally be detected by the naked eye. Note here, the The color of sewage can be normally detected by the naked eye. Odor. Odor. The odor of the fresh sewage is not offensive or practically it can be considered odorless, but as it starts to get stale, it begins to give offensive odor. Within 3 to 4 hours, all oxygen present in the sewage get adjusted and it starts emitting offensive odor by hydrogen sulfide gas, which is formed due to anaerobic decomposition of sewage. Within 3 to 4 hours, all oxygen present in the sewage get exhausted and it start emitting offensive odor by hydrogen sulfide gas, which is formed due to anaerobic decomposition of sewage. Note here, this one is color. Then is the physical characteristics. Temperature. The temperature has an effect on biological activity of bacteria present in the sewage and it also affects the solubility of gases in sewage. It also affects the viscosity of sewage. More is the temperature, less is the viscosity of the sewage. The normal temperature of sewage is slightly higher than the temperature of the water supply because of the additional heat due to utilization of water. Also, when the waste water flows in a closed pipe, its temperature future increases. The average temperature of sewage in India is about 20 degrees Celsius, which is near about ideal temperature of sewage for biological activities. At a higher temperature, coupled with the lower dissolved oxygen, activities can cause serious problems in disposal of wastewater. Physical characteristics. Turbidity. Sewage is normally turbid, representing dirty dish water or wastewater from baths, having other floating matter like fecal matter, pieces of paper, cigarette ends, matchsticks, greases, vegetable debris, fruit skins, soaps, etc. The turbidity depends on the quantity of solid matter present in the suspension state. The turbidity depends on the quantity of solid matter present in suspension state. The turbidity can be determined by the turbidity rod or by turbidity meters. Example, nephelometric. This is turbidity. Then is the chemical characteristics. Solids. Solids normally contain 99.9% water and only 0.1% of the total solids present in the sewage may be in the any of the four. Suspended solids, dissolved solids, colloidal solids and settled solids. Suspended solids are those solids which remain floating in the sewage. Dissolved solids are those which remain dissolved in the sewage just as salt in water. Colloidal solids are finely divided solids which remaining either in solution or in suspension. Settled solids are that solids which settles out if sewage is allowed to remain undisturbed for a period of 2 hours. Chemical characteristics. The proportion of these different types of solids is generally found to be as given below. It has been estimated that about 1000 kg of sewer contains about 0.454 kg of total solids, out of which 0.225 kg in a solution, 0.112 kg is in suspension and 0.112 kg is settleable. Also, solids can be organic or inorganic. About 45% of total solids are organic and the remaining 55% is inorganic. Inorganic matter consists of minerals and salts like sand, gravel, dissolved salts, chlorides, sulfates, etc. Inorganic matter consists of minerals and salts like sand, gravel, dissolved salts, chlorides, sulfates, etc. Then is the chemical characteristics. Organic matter consists of carbohydrates like cellulose, cotton, starch, sugar, etc. Fats and oils received from kitchen garbages, etc. Nitrogenous compounds like protein and their decomposed product, including waste from animals, urea, fatty acids, etc. Generally, presence of inorganic solids in sewage is not harmful. They can be removed by mechanical units in treatment plants, but the suspended and dissolved organic matters are responsible for creating nuisance if it disposed of without treatment. But the suspended and dissolved organic solids are responsible for creating nuisance if disposed of without treatment. Then is a chemical characteristics. The amount of various kinds of solid present in the sewage can be determined as follows. Total solids S1 in milligram per liter It can be determined by evaporating a known volume of sewage sample and weighing the dry residue left. The mass of residue divided by the volume of a sample evaporated will give total solids in milligram per liter. Suspended solids S2. These are the solids which are retained by a filter of 1 mu m pores, so they are called non-filterable solids. Their quantity can be determined by passing a known volume of sewage through a glass filter and weighing the dry residue left. Mass of the residue divided by the volume of the sample will give S2 in milligram per liter. Dissolved solids and collider S3. Difference between total and suspended solids, that is S1 minus S2, represents the dissolved solids and collider solids. Then is the chemical characteristics. Volatile and fixed suspended solids. The total suspended solids S2 may either be volatile or fixed. To determine their proportion, the non-filtered residue is burnt and ignited at about 550 degrees Celsius in a muffle furnace for about 15 to 20 minutes. Loss of weight due to ignition will represent the volatile solids in the sample S4, and S2 minus S4 will give the fixed solids S5. This is the solids. This is low turbidity to high turbidity. Then is the pH. The pH value of sewage indicates the logarithmic or reciprocal of the hydrogen ion concentration present in the sewage. It is thus an indicator of acidity or alkalinity of the sewage. If the pH value is less than 7, the sewage is acidic, and if pH value is more than 7, the sewage is alkaline. The fresh sewage is alkaline. With the passage of time, pH tends to fall due to production of acid by bacterial action in anaerobic or nitrification processes. However, with treatment of sewage, the pH tends to rise. Determination of pH is important because efficiency of certain treatments method depends on it, especially the biological treatment. For better result, the pH of sewage should be around 7.0 in biological treatment, as microorganisms can flourish in that pH range. pH can be determined using pH meter, potentiometer. This is pH. For pH is equal to 14, liquid drain cleaner. For pH is equal to 13, bleach. For pH is equal to 12, soapy water. pH is equal to 11, ammonia. pH is equal to 10, milk of magnesia. pH is equal to 9, baking soda. pH is equal to 8, sea water, eggs. pH is equal to 7, pure water. pH is equal to 6, milk, 6.5 to 6.8. pH is equal to 6 also stands for healthy lake, 6.5. pH is equal to 5, clean rain, 5.6. When maybe bananas, 5.0 to 5.3. Bananas or bananas, 5.0 to 5.3. Then pH is equal to 4. Aztec lake, 4.5. Not here. Here rain trout begin to die, 6.0. Here is the frog eggs, tadpoles, crayfish and may lice die, 5.5. Here is the all fish die, 4.2. pH is equal to 4. Then is the acid 4.2 to 4.4. Aztec lake, 4.5. Then pH is equal to 3. Orange juice soda. pH is equal to 2. Lemon juice vinegar. pH is equal to 1. Sulfuric acid. pH is equal to 0. Butyric acid. This is environmental effects, pH values and examples. These are the environmental effects. All fish die at pH is equal to 4. Frog as tadpoles, only fish and may lice die, 5.5. This is rainbow trout begin to die, 6.0 at 6.0. This is basic. This is neutral. This is acidic. Then H plus concentration, 10⁻⁻1, 10⁻⁻3, 10⁻⁻5, 10⁻⁻3, 10⁻⁻12.